All right, good morning, everybody. Another Physics Teachers Are Awesome reaction video. So this is Unit 2 Drop Project Instructional Video, slides 13 through 18. So kind of jumping into the middle of this, I guess. So let's see what's going on.
Hi, everybody. Here is our final installment for slides numbers 13 through 18 for our Unit 2 Drop Project.
Ooh, cool.
So here we are picking up on slide number 13, talking about momentum. Just a few more calculations. Now remember, when we calculate a momentum of a single object, you need a couple of things. You need your mass and your final velocity.
Cool.
You can find your mass here on slide number 8. So for my case, remember,
I love that. I love going back to earlier things that have been, talked about, say, hey, you've already got this. I'm just going to remind you exactly where it is. And so it's great. It looks like she has some common measurements here. That's super useful. But no, I really love just the going back part. So I just saying. There we go.
Mass here on slide number 8. So for my case, remember I did the tennis ball. We'll just go ahead and pretend I have a tennis ball. It's going to be 0.059. I'm going to go back here and place that in there, 0.059. Everybody's is going to be different. Just make sure you get the correct one.
Love that.
Our final velocity, that was on the previous slide in the previous recording on slide number 12. So if you just flip back to slide number 12, you'll go ahead and notice that our final velocity is a negative 4.41. Everybody's is going to be different. It's not going to be the same as mine. So I'm going to go ahead and put negative 4.41. Now that I have those two things, I literally just multiply them. So make sure you don't forget the negative number. So 0.059 times a negative 4.41, and I get...
I love that you can hear her punching it into the calculator. So she's literally showing, look, you can do this. Just grab your calculator, punch it in, we can do it. And then it's really interesting how she already has this negative sign in here, really sort of driving home that it's going to be a negative number.
A negative... Oops. It flipped back on me, a negative 0.26019. Okay. Now,
Awesome.
in order to increase momentum, well, there's a couple of things that I need to do. I need to increase my mass. When I increase my mass, I increase my momentum, or I increase my velocity. These are the two things that will help me to increase the momentum, is my mass, increasing my mass, and my velocity. Remember, please do not copy this. This is not your answer. These are not your numbers, so make sure that you do not copy this.
Easy way to
All
grade
right,
it,
let's
yes.
go ahead and take a look at slide number 14.
Oh,
It's talking about impulse. Now, we have talked about impulse yet, but in order to decrease the force your object experiences upon collision or hitting the ground, we need to make our time longer, and it takes for the collision to be completed. When we make our time longer, we decrease the force, and we decrease the force on impact, right? And we obviously decrease the injury.
So I'm guessing this is about maybe dropping something and hoping that it doesn't break or something, because that's what this would be all about. This is kind of what crumple zones are all about, right? And so it's really interesting when my kids and I talk about, my children and I talk about, the cars when I was younger. The crumple zones are really the biggest difference, right? When I was, really young, everything was like a tank, basically, and nothing did this. Just went, right, and went all the way into the soft parts, which is where the people are. And so this idea is really, really a great point. And I'm not sure if this drop project is trying to, protect something like an egg or something after it gets dropped. A couple of the example masses were like soccer balls and stuff, so those don't care about being dropped. But I think this is a really interesting point.
That somebody might have. That is why our cars are made now with so many bells and whistles and like automatic braking and all of these other things, is because what we're trying to do is to increase that time. That time should be longer to happen before impact. Before, older cars would not have that, and we would have much more force on impact.
That's a great point.
All right, let's take a look at slide number 15. Now, this is the slide for those who are doing the extra credit project. If you are doing the extra credit project, this is where you actually drop your egg. or your contraption with your valuable inside. Let's put it that way. So the first question is, did your object survive? Yes or no. Did your breakable object survive? You're just going to go ahead and highlight, erase, or box which one the correct one is. Now, to increase the likelihood your object survives, the time for the collision should be what? Just like before, talking about impulse, our time should be longer. The longer our time is, the less impact we have, the less deadly results.
There's an interesting point here about vocabulary, right? So we're trying to increase the likelihood of survival. We're trying to decrease the amount of force that it experiences, and then we want shorter or longer, right? And so we have this mix of sometimes we want the bigger word, sometimes we want the smaller word. So increase is a bigger word, and longer is a bigger word, but it's all about decreasing the force that it's feeling. So it's really interesting how she's getting her students to think very, very carefully about what's going on here, not just assuming that the vocabulary is basically given away by the question.
That's mainly how it goes when we are talking about time for collision. And then finally, this one is over here. What is something you could do to your contraption to improve your design? You type it right there.
Cool.
If you are not doing the extra credit, do not do this slide. This is only for the people who have done the egg drop experiment
So it's really interesting that basically this is their work book or whatever you call it. It looks like it's a Google Slides. So she's likely sharing, probably asking students to make their own copy. What's really cool about that is that it builds the scaffolding they need to sort of think about the stuff that they should be doing and makes grading pretty straightforward, right? I mean, she really is explaining how the pieces and parts fit together and how they need to sort of be shown on the work. So I think that's really, really cool. I think that this walkthrough is super useful to the students. It helps, especially as you listen to her, she's describing why something's happening, why we might care, and in this extra credit example, really taking it to the next step. So I really think that's great. I think I'll stop here. I think that this idea of a scaffolded, what would you call this, lab or project document is really interesting. I am curious about, how, when you do scaffolding, scaffolding is meant to be pulled away, and so I wonder if later in the term she does less of this, or if she talks with her students about what they should be doing when they maybe start from scratch. I think that definitely though this is scaffolding for a reason, right? You need to sort of hold things up. You need to hold your students up and help them understand the really important parts that matter. So I think that's really, really great. All right, everybody. Well, have a great day, and remember, physics teachers are awesome.